the probability in S1, that's paper number 5, June 2021, variant number 2. Let's look at the very first question. The very first question says, an ordinary fair die is thrown repeatedly until a 5 is obtained. Now, this is the terminology for geometric probability distribution. The number of throws taken is denoted by the random variable x. Write down the mean of x. Even before that, probability of getting a 5 is 1 over 6. X follows a geometric probability distribution with 1 over 6. Probability of success is 1 over 6. Expectation, that is the mean, that is equals to 1 over p, which is 1 divided by 1 over 6, which comes out to be 6. So that is the expected value of this particular distribution, which is called the mean. Second part, find the probability that a 5 is first obtained. So 5 is first obtained after the third throw, but before the 8th throw. So it could be 4th, it could be 5th, it could be 6th, it could be 7th. So these are the 4 possible throws that you can have. So therefore, probability x is equals to 4. That would be 3 failures and 1 success. Probability x is equals to 5. That is 4 failures, 1 success. Probability x is equals to 6. 5 failures, 1 success. Probability x is equals to 7. That is 6 failures, 1 success. So you can simplify if you want to. You can take as much common out and then substitute. That's also a nice way of working it out. So therefore, probability x lies between 4 and 7 inclusive. So that is q cube p plus q power 4p plus q power 5p q power 7 is actually 6. So let me correct this thing. This is actually 6. So that is q power 6 and then a p. What can you take common out? You can take p common out. You can take cube common out. And that is 1 plus q square plus q cube. Now plug in the values. Remember, p is 1 over 6, q is 5 over 6. And then once you plug it in, you get the answer. So that is 1 over 6, 5 over 6 cube, 1 plus 5 over 6 plus 5 over 6 square, and 5 over 6 cube. Or you can add up the terms individually and you still get the same answer. The next part, it says that find the probability that the 5 is first obtained. 5 is first obtained in fewer than 10 throws. So probability x is less than 10. It's a discrete probability distribution, so you have to change it into an inclusive inequality. That is, x is less than or equal to 9, which is too much to calculate. There is a shortcut. What is that shortcut? And that's very useful. Probability x is less than or equal to n is 1 minus q raised to power of n. Probability x is less than or equal to 9 is 1 minus q, which is 5 over 6 raised to power of 9, and then you get this answer. Now in this whole question, work in fractions. So that is very, very suitable throughout this whole question, because the decimals won't be exact, so you have to worry about accuracy. So work in fractions throughout this particular question. So question number 1 is done. Question number 2, it says the weights of bags are normally distributed with mean 1.04. Normal distribution 1.04 and standard deviation is sigma, variance is sigma square. In a random sample of 200 bags, 72 weighed more than 1.10. That means probability x greater than 1.10 is 72 over 2000. which after division comes out to be 0.036. Since this probability is lesser than 50%, flip the inequality. X lesser than 1.10 is 1 minus 0.036, which comes out to be 0.964. So probability x less than 1.10 is 0.964. Now it's in a superfit condition for you to carry on with the rest of the step. Probability z is lesser than 1.10 minus 1.04 divided by sigma equals to 0.964. Now we will go to the table, and there is the table 964, and let's locate this probability. So I can see 9641. I think, will this work out? 9641. So 9641, the corresponding z value is 1.80, but officially you should go for lesser, that is 9633, and I'm looking for 964. 964, that means I need 7, so I should choose this value. So 9633 plus 7 is 9640. So this is your 1.7, this is your 9, and this is your 8. So 1.798, that is the corresponding z value. So the corresponding z value is 1.798. Because of this lesser sign, z value is positive. Probability z is lesser than 1.798 equals to 0.964. Therefore 1.10 minus 1.04 divided by sigma is 1.798 positive, and therefore you will find the value of sigma, which comes out to be 0.0334, correct to 3 significant figures. Now this was a question, a simple question on normal distribution. So let me label it over here. So this is normal probability distribution. And was there anything special in this thing? The only thing special was just taking care of all these probabilities and z values and the plus and the negative sign and so on. Question number 3. It says on each day Alexa goes to work, the probabilities that she travel by bus, by train, by car are such and such and such respectively. Now let me first draw 3 branches of this tree diagram. First branch, and then the second branch, and then the third branch. These are the 3 branches of this tree diagram. It's bus, train and car. Always keep the same order. So this is bus, this is train, this is car, this is 0.40, this is 0.35, this is 0.25. It all adds up to 1 because these are the only 3 modes of transport that she uses. Now after this, what else is there? Let me choose a green one and let me choose an orange one. So now a branch like this, a branch like this, a branch like this, it's about getting late and it's about not getting late. So therefore they are not using the term early, so it could be on time, it could be earlier. So basically this is late versus not, late versus not, late versus not. For the bus thingy, it's about 0.55 and 0.45. For the train, it's 0.7 and therefore this is 0.3. And for the car, she arrives late is x and this is 1 minus x. So there are 6 options. It's a bus late, bus not late, train late, train not late, car late, car not late. Now it says further, on any randomly chosen day when Alexa goes to work, the probability she does not arrive late is 0.48. Therefore, I need this one, 0.40 into 0.45. Let me write it, 0.40 into 0.45. I'm interested in this one. Train not late, that's 0.35 into 0.3. And last but not the least, that is 0.25 into 1 minus x. So therefore, train, no, she is not late. That is the combination, the addition of these three, that is Bn plus Tn, and this one, last one, is Cn. So this is 0.40 into 0.45, this is 0.35 into 0.30, and this is 0.25 into 1 minus x. It all adds up to 0.48. That's already given. You do the calculation and you get the value of x comes out to be, this thing comes out to be 0.22. That is the answer for x. That is simple. Find the probability that Alexa travels to work by train given that she arrives late. So now the possibility of late, that would be the denominator. So let me write it directly. That would be bus late, train late, car late. That is how much? So this is 0.4 into 0.55. So this is 0.4 into 0.55. And this is 0.35 into 0.70. And CL, car late, that is 0.25 into, this is 0.25. This is not 0.2. I think I made a mistake of writing it over here. Let me correct it. So this is in blue color, and that is 0.25 into 1 minus x. So therefore this is 0.25 into 1. This time this is x. So x is 0.22. This is your denominator. This is your condition. Condition goes down in the denominator. And then it says Alexa travels to work by train. So this train concept, this train numbers, this thing will go at the top. So therefore train late goes at the top. That is 0.35 into 0.70. Now when you do the calculation and when you divide, this comes out to be nice fractions, which is 149 over 104. It's the calculator that will give you this. So you don't have to worry much about it. Leave the answer intact. Leave the answer in fractions. So this question was about probability, and naturally it was about a tree diagram which we just saw, and in that tree diagram it was about the concept of conditional probability. Question number 4. This question is about what? A fair spinner has sides numbered 1, 2 and 2. So there are 3 numbers. Let me change to these. So this is 1 and this is 2 and this is 2. So this is 1, 2, 2. Another fair spinner has sides numbered such and such. Each spinner is spun. The number on the side on which a spinner comes to rest is noted. The random variable x is the sum of the numbers of the 2 spinners. So let me write it like this. Let me draw a sample space diagram. And over here, this is 1, 2, 2. There are 9 options. This is 1 and this is 2 and this is 2. Put a plus sign over here. And this is minus 2 and this is 0 and this is 1. So when I add it up, let me add it row by row. Minus 2 plus 1, minus 1, minus 2 plus 2, 0, and this is 0. 0 plus 1 is 1, 0 plus 2 is 2 and 2. 1 plus 1 is 2, 1 plus 2 is 3, and then a 3. Now how many numbers do you see? You see the number 0 twice. You see the number 3 twice. You see the number 2 thrice. You see the number 1 once, and you see the number minus 1 once. So there are 5 options. So your table is pretty straightforward. It's like this. And your x is the sum. This is the probability. Start from the lowest, that is -1, and then a 0, and then a 1, and then a 2, and then a 3. So -1 is 1 over 9, 0 is 2 over 9, 1 is 1 over 9, 2 is 3 over 9, and 3 is 2 over 9. Double check. So it's 1, 2, 1, 3, 2. It all adds up, and you have done the calculation correctly. Find expectation and variance. That's kid stuff. expectation of x, that is sigma px. So therefore this is minus 1 into 1. Let me shift it to the side so I can do all the working once. Minus 1 into 1. This one is 0 into 2. This one is 1 into 1. This is 2 into 3. This is 3 into 2. Everything added together divided by 9. So therefore this comes out to be minus 1 plus 1 cancel. 6 plus 6 is 12. This is 12 over 9. If I want to do the calculation for expectation of x square, so this is sigma px square. Let me write it properly. That is E. So therefore, this thing should also go a bit on the side. And let me draw a line somewhere here in the middle. And for expectation of x square, that is minus 1 square is 1 into 1. And this is 0 square into 2. Minus 1 square into 1, 0 square into 2, 1 square into 1, 2 square into 3, and 3 square into 2. Divided by this thing, which is 9. So therefore this is 1. This is 1. So that adds up to 2. And 4 3s are 12. And 9 2s are 18. So 12 plus 18 is 30. That is 32 over 9. And last but not the least, that is variance of x. That is expectation of x square minus square of expectation of x. That is 32 over 9 minus 12 over 9 square. That is 32. This is not 39. 32 over 9 minus 144 over 81. So let me get this right. 8 9 9s are 32 9s are. So 32 multiplied by 9, that is 288 minus 144, which is 144. So this is 144 over 9 divided by 9, and this comes out to be 16. Let me double check. Yeah, it is 16. So therefore this answer for this particular part, this comes out to be 16. That is the variance of x. Actually this is 81. This is not 9, my bad. So this is 144 over 81 after the LCM. Leave it as it is. And what else is it asking for? It's asking for expectation. That's done. And variance. That's also done. Question number 5. Now question says, every day Richard takes a flight between Astana and Beijing. And what is the flight about? The probability the flight arrives early is this much. And it arrives on time is this much. And it arrives late is this much. So there are 3 possibilities. It's early, it's on time, and it's late. So now it says find the probability that on each of 3 randomly chosen days, Richard's flight does not arrive late. That means it can arrive early or it can arrive on time. Got the idea? So probability of success, probability of late is 0.3. So probability of not late, that is what my focus is, that is 0.7. Now there are 2 approaches to this question. So people could think in different ways. I can consider that not late as my success, or I can consider late as my success. So let me explain both the methods. This is the first method, because this is a simple question, but people do get confused. And this is the other method. So now if I say that my success is late, so I'll write x follows a binomial distribution 3, 0.3. And if success is late on each of the 3 randomly chosen days, he is not late. So probability x is equals to 0. That is 3C0. Success raised to power of 0, failure raised to power of 3, which is 0.7 raised to power of 3, and whatever this answer comes out to be. 0.343. That is 7 cube divided by 1000. If my success is, let me erase this thing. If my success is not late, so therefore X follows a binomial distribution 3, 0.7. And not late is success. So all 3 days he is not late. So probability X is equals to 3. That is 3C3. Success is 0.7 raised to power of 3. This is 0.3 raised to power of 0, which is 0.7 raised to power of 3, which is 0.343. So that is the answer for this particular part, done in 2 different ways. Now, second part, find the probability that for 9 randomly chosen days, Richard's flight arrives early. So arrives early, that is the success. At least 3 times. So you would write X follows a binomial distribution 9, early is success, that is 0.15. That is for early. At least 3, probability X is greater than or equal to 3, which is 3, 4, 5, 6, 7, 8, 9. Too much to calculate. 1 minus probability X is less than or equal to 2, which is 1 minus 9C0, that's the first term, 9C1, that's the second term, and 9C2, that is the third term. Just plug in the values. This is 0.15, this is 0.15, this is 0.15, this is 0.85, 0.85, 0.85. Now your success is 0, so this is 0, and this is 1, and this is 2, and 9 minus 0, that is 9, and 8, and 7. And then you write down all the possibilities with the correct significant figures. 1 minus 0.231617, 0.367862, plus 0.259667, and then you do the subtraction and then give the answer correct to 3 significant figures. So that's the working for this one. And the examiner requires every single piece of work. Part C. What is this all about? Of course, it's a binomial question, but this is an extension. So therefore, this is normal approximation to binomial. When it says suitable approximation, that means normal approximation. It says Richard's flight arrives early at least 12 times out of 60 days. So first of all, you would say X follows a binomial distribution 60, 0.15. Write all the data separately. N is 60, P is 15%, Q is 85%. So 60 into 0.15, that comes out to be 9. So therefore NP comes out to be 9. And NQ comes out to be 51. And I'm writing NP again as 9. And NPQ, that comes out to be 7.65. The first 2 red clicks, that is for the justification, whether the examiner asks it or not. Since NP is greater than 5 and NQ is greater than 5, therefore X follows a normal distribution, something, something. What goes in the something? NP goes, which is the mean, and NPQ goes, which is the variance. So this is 9, 7.65. That is the working for this one. So now let me write 9 in a proper manner. This is 9 and like this. And then it says at least 12. So let me draw a number line first. And it says probability X is greater than or equal to 12. Probability X is greater than or equal to something. Probability Z is greater than or equal to this value minus 9 divided by square root of 7.65, and then so on. Now first of all, this is 12. This is 12.5. This is 11.5. There are 2 options available, the red option and the purple option. Since this is inclusive, therefore the correct option is 11.5. So therefore, this is 11.5 after CC, continuity correction, 11.5 minus 9 divided by root of 7.65. This is probability Z is greater than or equal to 0.9039. That is a positive value, which is 1 minus phi of 0.9039. Read the table, subtract the probability, 1 minus 0.8169, which is 0.183, rounded off to 3 significant figures. So that's the working for the normal approximation to binomial. Now, this looks like a question of permutation and combination. You might have seen some dollar bills sticking over there. We'll come to that in a short while. NPR, NCR. Now, let me keep this question for last. It's a very, very interesting question. So I want to end the class at a high note. Let me come to this question first. This is about stem plot, box plot, stem and leaf diagram, interquartile range, and then some mean. So basically, this is about some descriptive statistics, or this chapter is also known as representation of data. Now the question says, first of all, the heights in centimeters of 11 basketball players in each of the two clubs, the Amazons and the Giants, are shown below. State an advantage of using a stem and leaf diagram compared to a box and whisker plot to illustrate this information. Now, first thing first, that is, in a stem and leaf diagram, the original data is preserved, whereas in a box and whisker diagram, the original data is lost. And once you have the original data, you can use it to find mean and standard deviation and variance and median and interquartile range and so on. But this is not a strong thing because this thing is already there. So therefore, ignore this. But mean and standard deviation and range, the highest value minus the lowest value. So things like that, that is already there in the original data. If, for example, the examiner would have asked the advantage of stem plot, actually the other way, the advantage of box versus stem. So we can talk about the 5-point summary. What do we have? We have the lowest value, we have the lower quartile, we have the median, we have the upper quartile, we have the highest value. Actually, these three are the most important thing right away. What else can you see? You can see the skewness of the distribution. So that is the advantage of box versus stem. Now it says represent the data by means of a back-to-back stem and leaf diagram with Amazons on the left hand side, because the examiner is in no mood of looking and sorting out your data. So it needs things in a proper, neat manner. So let me draw some lines over here. And let me just shift it a bit. And let me draw 1 or 2 more lines like this. So 1, 2, 3, 4, 5. I think this is enough. And let me draw a stem somewhere here and a stem somewhere here. And let me take out a standard eraser and something like this. Achha. Now, first of all, look at the Amazons. What is the lowest value that you see? So in Amazons, the lowest value 181 and 178. 178 is the lowest, and the highest value that I see is 215. So the numbers could be like 170s and 180s and 190s and so on. So the very first thing that I'll write is that I'll write over here 17, 18, 19, 20 and 21. Left hand side is the Amazons and the right hand sides are the Giants. Now in the Amazons, when we sort out the data, we would start from the lowest, the 178, that is the one. So let me write 1, 7 and 8. And then the next one, what I see is that is 181 and then 182 and then 184. And then similarly, I can see 190 and 196 and 198, and you can make telemarks 201, 202 and 205 and 215. So 3 that is 9 plus 2 is 11. The 11 players, that's perfect. So also mark it like this. This is 1, this is 3, this is 3, this is 3, this is 1. The total is 11. It's not necessary that it will always be equal. It's not any rule as such. So let me just erase this. Now on the right hand side, let me write it in purple. The smallest value for giants is 175, and there is no other 170 value, and in the 180 value I can see 182 and then 184 and 187 and 189. So this is 1 and this is 4. In the 19 series, that is 2 and 3 and 5, 5, 5. So this is 2 and 3 and 5 and 5 and 5. So this is 5 of them. In the 20 series, there is 4 and there was nothing in the 21 series. So double check. This also adds up to 11. Now you also need a key. So on the left, the key is 5/21 means 215. This is the data for what? Amazons. So this is for the Amazons, and on the right hand side, the key would be 20/4 means 204. This is for the giants. So a key for Amazonians and a key for the giants. That's how it goes. Now what else are we looking for? Find the interquartile range of the players in the Amazons. Now how many players are there? There are 11 players. Now think very closely. I'll do the working over here. I'll draw 3 strips, 1 and then 2 and then 3. 1 for the median, that is Q2. 1 for the lower quartile, that's Q1. Then for the upper quartile, that's Q3. So let me start with Q2. 11 divided by 2 is 5.5. Round it up, that is the 6th value. So the 6th value is the median. Let me wait a minute. Let me change the color so that it looks nicer. So let me choose the stroke eraser and then this eraser. So the pink one is the one in the middle. So 1, 2, 3, 4, 5, 6. So this 196, that is the median. So 196 is the Q2. That is the answer for this particular one. And then what does it say? This is for the Amazonians. Correct? So Amazons are the one on the left. And then it says, they're not asking for the median as such, but I just calculated it. So now let me do the calculation for the lower quartile, because the median is the 6th value. 5 values are lower ones. Which are the 5 lower values? The 5 lower values are 1, let me make it thinner, this one, this, and this. Among these 5, which one is in the middle? So 1 in the middle is this 2. 2 below it, 2 above it, so 182. So therefore the lower quartile is 182. Similarly, the bigger ones, let me choose another color. So now upper quartile is like this, and since we have used blue, so let me choose some other reddish one. So upper quartile, this is 5 values above the median, 1 and 2 and 3 and 4 and 5, and which is the biggest one out of this? The biggest one is 202. So therefore the upper quartile is 202. Therefore the interquartile range is upper quartile minus lower quartile, which comes out to be 20. It's UQ minus IQ. So UQ minus LQ, upper quartile minus lower quartile. Now this thing is done. That's the interquartile range. Now the last question, the last part of this question. There is one question that we have left out. We have to go back over there. 4 new players joined the Amazons. The mean height of 15 players is now 191.2. So there were 11 old players and 4 new. So altogether that's 15 players. It's just basic everyday maths. Sum of heights of 15 players. How much is that? So that is 15 multiplied with 191.2. Let me do the calculation. So this comes out to be 2868. This is 2868. Sum of height of old 11 players. You just have to add it up. That is sigma x. Let me grab my calculator. That is 205 plus 198 plus 181 and so on. Let me add it all up of these. So wait a minute, let me add it. So when I add these values, it adds up to how much? 2132. So this adds up to 2132. Then new 3 players, because we want to find the height of the 4th one. That is 180 plus 185 plus 190. And now the age, no, it's not the age, it's the height. Height of 14 players. So that is 2132 plus 180 plus 185 plus 190. And let me get this one. Therefore, 2132 plus 180 plus 185 plus 190. This adds up to 2687. Therefore, the difference between 2868 and 2687 minus 2868, this comes out to be 181. So the difference, that is the height of 15th player who join in. That comes out to be 181 centimeters. So I think some very basic question that they have asked. Now let's come back to this question, which is one of the most classiest question of permutation and combination. So let's get started with this one. Now the question says, first of all, that we have the word which is tomorrow. T-O-M-O-R-R-O and W. So there is a T, there is an M, there is a W, and then there are, let me highlight it, 3 O's, and then there are, let me choose another color, almost the same. Let's choose green. 3 O's, 2 R's, and TMW. Now the first thing is different arrangements, that is 8 factorial divided by 3 factorial for the O's, 2 factorial for the R's, 3 factorial for the O's and 2 factorial for the R's. So this is O's and this is R's. This thing is done. That's the first part. This calculation comes out to be 3360. That is straightforward. The total number of different arrangements of 8 letters of the word tomorrow that have an R at the beginning and R at the end. So there is an R at the beginning and there is an R at the end. So R at the beginning, one option because it's identical. R at the end, another option, it's identical. And the 3 O's are not all together. That means the easiest way, there is more than one way. The easiest way is to find 3 O's are together and then subtract from part A. That is the easiest. If someone is more interested, there is a video which I'll place in the comment box, and in that one I have explained the other way also. Also, this question is very similar to this question that came earlier about the word green gauge. Do look it up. So first of all, if three O's are together, so let them be together. So when three O's are together, what will happen? They will be in a box. So O's are in this pink thing. So therefore there are three in this. So there is an O, there is an O, there is an O. It's in a box. And what is left? So there is TMW left. So there is T, there is M, there is W. Now 1, 2, 3, 4, that is 4 factorial. What is happening inside the box? Nothing is happening, because 3 factorial divided by 3 factorial for the O's, so nothing is happening. So therefore this answer comes out to be 24. That is the answer for the first part. Now in this scenario, subtraction from A, that what I mean is that the subtraction in which without any restriction, subtract from without any restriction. The restriction is there of that R and R, that's not an issue. So let me write this thing. R at the front, R at the end, R at the front, R at the end, there is 1, there is 1. And this is O, 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 T, M, W, that is 6 factorial divided by 3 factorial, that's 120 divided by 6. 720 divided by 6, that comes out to be 120. Sometimes I blurt out the answer before the working. Therefore, the difference is 120 minus 24, that comes out to be 96. That is the working for this particular part. That is 6A and 6B. And now comes a question which is the first time that people have seen it, because usually this question is about the number of ways, and that is the easy one. This is about probability. Now why have I put in $300 bills over here? The first thing is, if I have $300 bills in my pocket and the waiter comes and the bill is $100 or lesser, so I'll just give one of the bill. It doesn't make a difference which one, and the other two remains in the pocket. It doesn't make a difference which one I give. So this scenario is whenever this question was about selection and the number of ways. So this question was about that. But if the question is asking about probability, so even though the $100 bills are identical, when we talk about probability, it's 1 out of 3. Now this concept will be applied over here. When we have the word tomorrow, we have 3 O's and 2 R's, and let me first write it. So I have 3 O's and 2 R's. So let me first write TMW first. So this is T, and this is M, and this is W. And then I have 3 O's. Let me write it this. And the 2 R's, that is in green, like this. So let me push this down a bit, and let's see how many possibilities are there. So there are 3 possibilities over here. There are 3 possibilities because this time I'm talking about probability. It's not about the number of ways. Yes, they are identical, but the $100 bill example, $300 bill in your pocket, and your friend wants one of them. So the chances are you'll be giving him 1 out of 3 is in terms of probability. So now it says you need at least 1 O and at least 1 R. So 1 O and 1 R, that means out of the total of 4, you would choose 2 from here. That's one option. Now keep on increasing. 1 and 2, 2 and 1. So in 1 and 2, this comes out to be 1. In 2 and 1, this comes out to be 1. What about these 2 and these 2? That's possible. So when these 2 and these 2 are possible, this becomes 0. And there is also this option, because since you have 3 O's 1 hour, and this is 0. These are the 5 scenarios that you should look for it. And let me remove this, actually not remove it, just reduce it. And this goes like this. The dollar bill is also reduced. So let me first just shift this down. And now I'll reduce it. So therefore, that's the logic for this. Let me move this thing over here. Like this. And now let me write it. So the answer is, for the purple one, this is 3C2 into 3C1 into 3C1. Whatever the answer comes out to be. Second one, 3C1 into 3C1 into 3C2. 3C1 into 3C2 into 3C1. This is 3C0 into 3C2 into 3C2. This is 3C0 into 3C3 into 3C1. The first answer comes out to be 3 into 3 into 3. So therefore 3C2 is 3, 3C1 is 3, and this is 2. My bad, this is not 3. So I think I've mistakenly written 2, 3 all along. So this is 2. So let me write it in red. So this is 2, this is 2, this is 2, this is 2, and this is 2. So therefore this is 2. Now multiply. 3 into 3 is 9. 9 into 2 is 18. That is the first answer. Second one, 3 into 3 into 1. That comes out to be 9. 3 into 3 into 2. That comes out to be 18. 1 into 3 into 2. 1 into 3 into 1. That is 3. And 1 into 1 into 2. That is 2. So these are the 5 possible answers that you will end up with. Let me highlight it. This is 18, 9, 18, 3, and 2. So when I add these up, this total comes out to be, let me add it up, 5, and 5 plus 9 is 14. 14 plus 36 is 50. So this total is 50. And without any restriction, the probability. So when they say that probability that the selection contains at least 1 O and 1 R, so that is the number of ways. That is 70. How do you get this 70? Because there are 8 alphabets and you are selecting out of them. You are selecting 4. So therefore that is 70. So therefore the probability of this coming out, that is 50 over 70. That is the answer for this particular part. So now that completes this thing. Let me do one double checking, and that is over here. So this is 8C4, 50 divided by 8C4. This is 8C4, and this is the answer. That comes out to be 5 over 7. So that completes our paper, which is May-June 2021, variant 52. Take care.